Hello there, I'm Thomas, the pilot flying the Boeing 767-300ER aircraft in this flight from Zurich International back to Zurich International. We're going to be flying at flight level 250 to 35,000 feet with Mach 0.82 or 340 knots approximately. And right now I'm in the cockpit for the pre-takeoff preparation, and I'm going to be showing you some of the Boeing 767 aircraft systems and make some explanation of the system, and also I'm gonna make an engine start demonstration. So I'm gonna show you now. Here we have the cockpit with all the instruments of the Boeing 767-300 aircraft. You can see here we have the control wheel with a yoke. I use this to modify the flight control surfaces to make the aircraft bang roll to the left or to the right, or pitch up or pitch down in flight. And I use this Logitech Extreme 3D side stick to control this, and also control the thrust levers using this control tab here. And you can see the overhead panel over here. So maybe I'm gonna have to start showing you some of the engine start demonstration I was been talking to you about. So before doing anything else for engine start, first of all we're gonna make sure we have the flap levers. The flap lever is to the 0 up position. The speed brakes is in the up position, is retract, and flaps are retract. The thrust levers are at idle, as you can see here. If I move the thrust levers all the way up right now, because the engine is start and running, you can see we have the N1 here is increasing to 92% right now, 93, 94, and one is the front of fan low speed rotor, low pressure compressor stage of the engine. The exhaust gas temperature, it can go up to the 700 degrees, maybe 750. Here we have the N2, which is the high pressure compressor stage, high speed rotor stage of turbofan engines, 102% right now. The fuel flow is 20,000 pounds per hour per engine. 23,000 pounds. This is the takeoff thrust. The oil press right here of the engine, the oil temperature and oil quantity, 83 degrees and 10 quarts per engine. And here's the N1 and N2 vibration per engine. And here we have I'm gonna be showing you later some of the. Here we have the thrust reverse. If I move this in the back, this lever engages the thrust reverse. So I have to set the engines at idle and then move the thrust lever, the thrust reverses. Here we have maximum reverse right now, I guess. So I'm gonna be showing you here. You can see the thrust reverser is deployed right now. We're doing the thrust reverser right now. So I'm closing it off. So I'm gonna be showing you here. Here we have the hydraulics panel section of the overhead panel with the left engine and right engine hydraulic power compressors and electrical backup, and electric 1 and 2, and we have the controllers for each engine and its electrical backup. Here we have the electric engine controllers, which is similar to the FADEC, the full authority digital engine control we have today in Boeing and Airbus aircraft, most of the CFM engines, which controls all the parameters of the engines that are displayed over here. in the ACAS, Identification Controller System. So this should be in the normal for engine start. Here we have the yaw damper, which minimizes the yaw of the aircraft. I'm going to be talking about in another section. Here we have the air data inertial reference system, which fits the aircraft with GPS positioning, with inertial and air data like air pressure, angle of attack of the aircraft with respect of the airflow, and other factors like gyroscopic precession and magnetic compass, which is causing one kind of hybrid GPS position, which is displayed here in the navigation display in the primary flight display. It shows the attitude of the aircraft, and also it's applied here in the flight management computer, which manages the flight control unit, the autopilot, later on in vertical navigation. So I'm going to be talking later about this. I'm going to try to start the engines quickly. So this is the air data inertial reference system. I have it in the nav position right now. It's still in the align mode. I don't know why. It should be displaying our position right now. It says T154. So 215. This is the difference between the true and the magnetic. 152 I believe is magnetic, and T is the true is 154 degrees heading of the runway. Here you can see the heading displayed over here, 153 right now, which is in the middle between 152 and 154, between the magnetic and the true. So here is the fuel pumps for its no, this is the electrical panel. Here is the fuel pumps. This is the left wing fuel pumps, the right wing fuel pumps, the primary fuel pumps, and the standby fuel pumps, and the center tank fuel pumps. We have to turn them on for starting the engines. So here is the fuel quantity displayed for each engine. I think I have to turn on some of the lighting here. Yeah, it's gonna make it more convenient. Here is I was showing you the air data inertial reference system. You can see it better with the light right now. The yaw dampers, the hydraulic panel, the electrical panel, and the fuel pumps over here, the fuel panel. Here is the fuel quantity for its wing tank, 5.2 thousand kilograms and 5.2 thousand kilograms, and the center tank is 10.8 thousand kilograms. Fuel temperature 20.7 degrees, and total quantity is 21.2 thousand kilograms. It's about 48,000 pounds. So here you can see the engine start selectors. We use this section of the overhead panel to start the engines. We have the engine master switches, engine mode selectors in the auto right now, and we will turn them in the ground for starting the engines. And here we have the ignition for each engine, some other here is the anti-ice. We need to have it off right now for starting the engine, so I'm gonna leave this off. The lights of the aircraft, the exterior lights, like we have the anti-collision lights, position lights, logo lights, and landing lights. So maybe we need this is the pressurization panel of the aircraft, the cabin pressurization. We need to set this in the landing altitude of the airport that we're gonna take off and land. This is the destination airport, same like the departure airport right now. So I'm gonna set it about 1,400 feet, 1,429 feet. So here we have the pressurization controllers mode selector, which lets in the automatic alternate one, which is also automatic, or manual control of the pressurization of the aircraft using the outflow valves manually for climb or descent, which opens the outflow valves when we descend or closes them when we glide to pressurize or depressurize the cabin. Here we have the auto rate, which is manual. So we're gonna leave this in the automatic mode. So we need also to start the APU. Here's the electrical panel I was telling you. Here is the left engine and the right engine contactors controllers, which connect the engine alternate current generator when the engine is running. They also connect the APU when the APU is running, and the external when we are in the ground and we need some external maybe electrical power. So I'm gonna let this we have also in the battery here which is on right now, and here is the standby selector. We have it in the auto. We can leave it in the battery or in the off position. Some other contactors, the utility bus and the bus ties, I'm gonna be explaining in another section maybe. So now we're gonna start the APU using this controller in the start for like a few seconds until we have the run over here, and then we leave this is spring loaded back to the on. So we're gonna have the APU running like a minute. You can see the APU exhaust gas temperature here is increasing to 140 degrees, rotation per minute 75. We have to reach about 100, I believe. So we have the APU available now. So when we have the APU available, I can show you how to start the engine. So I'm gonna try to do this very fast for this flight, because we have only 55 minutes to complete this video. So the APU is already connected in the contactors. So if we gonna disconnect the engines, we're gonna have electrical power from the APU. So here is the engine's master switches, which closes the low pressure and the high pressure pumps valves. And here you can see the engine is running out, it's slowing down. You can see it maybe here. I cannot give you a closer view of the engines right now. I have both engines off, so I'm gonna come up here. We have the APU available, it's running and connected to the electricals. So I'm gonna turn this maybe in the auto position. This is the hydraulic pumps of the engines. When we are gonna have the engines available, we're gonna pressurize the hydraulic systems. Here we have the fuel pumps all running. We only need to use the APU pressurized air. Here's the pressurization panel of the aircraft, and here is the engine and the APU pressurized air, which is bleeding to the system to pressurize the cabin and pressurize the hydraulic fluid, which also controls the aircraft flight controls, like the ailerons, the spoilers, the horizontal stabilizer, the elevator, and the rudder, and also is used for nozzle steering and braking, and also for engine thrust reverser and other functions, and air conditioning. I'm gonna turn this the packs off. We have it in the knob right now. So I'm gonna maybe let this on also and use the isolation valve. So we have fully pressurized air from the APU now. It's running to the engine starter. We want it to run towards the left engine. We're gonna start the left engine first. So I'm gonna use this, and here we have it. Pressurized air into the engine start compressor, engine starter. So maybe so you hear the engine starters. We have the N2 21% as we needed for engine starting. Some fuel flow is 0.1% right now, should be more than that when we turn the engine master switch. So I'm gonna be showing you, we start this engine first, the left engine. It is running a little bit. It's still in this mode. So gonna come back to this and let the engine master switch, which lets the low and high pressure fuel valves on. And here we have it. You can see how rapidly the engine is starting. You can see some warning messages here: right fuel, center hydraulic system pressure, right engine, oil pressure, right hydraulics, primary pump, right generator off, center, right fuel pumps, fuel configure, FMC message, hydraulics. And we have the engine running, the left engine at least. You can see it here. It's spinning. So I'm gonna come now for the right engine. I'm gonna start this engine start selector, the right engine. And here we have the right engine also responding to that. %, and 2, so we can start the right engine start selector. And here we have it. The right engine is spinning, as you can see, and the left engine. We need to reconfigure the left engine. I did mistakenly close the engine master switch. Here we have it, 70, 80, 90, 21. I'm gonna let this run also. Now I can start the packs. Maybe turn them in the auto position. Turn off the left and right isolation. And have some pack air for on the ice. So this is it for the engine start. Gonna use this in the auto. Turn on the hydraulics, the left and the right. I'm gonna leave the yaw numbers off. So I'm gonna use the flaps for takeoff, maybe 15 degrees of flaps. We're almost ready to go for takeoff. I only have to set the flight management computer and the autopilot. So coming to initial gross weight, it should be 298,000 pounds. Zero fuel weight, well, it should be 298,000. Zero fuel, yeah, we have it correctly, 251.9 thousand pounds. So we have about 48,000 pounds of fuel, and the results should be 5. The cost index should be 100 and the flight altitude 25,000 feet. So 250, 25,000 feet, and the cost index 100. So I'm gonna be showing you the route Lszh 8 and back to Lszh 8. So I'm gonna be using the radar also, so I'm gonna turn this on. WXA maximum gain, and here we have the transponder and the TICA system, which I'm gonna be explaining another time. So I'm gonna turn the TICAs on too. So we have an aircraft here displayed. So runway, maybe have another runway 16. Departure arrival runway maybe 16, and so I'm gonna set the flight plan here. You can see we have other radar display some clouds and some terrain. So and the arrival here, we have a Lszh 14, Trans Negri 1 Alpha and Trans Summit. Gonna press the activate. We're gonna have the whole flight plan here created. So you can see here the whole plan. Yeah, we have better display right now. So I'm gonna have to set the autopilot in the LNAV, flight director zone, auto thrust arm. Gross weight, takeoff performance. We need flaps of 1.5 and V speeds 128, 133 and 142 is V2. V rotate 133, V1 138. So I'm gonna set a higher speed in the airspeed here, the airspeed dot. So this is so much for this flight plan, I believe. So we're gonna use a center of gravity of about, you can see how I trim up the aircraft. The flap position should be 1.5 right here, and the stabilized trim is correctly set. So is 25.8%. And here we have the trim 2.69, the V speeds, the flight plan, the legs. So I'm gonna use the LNAV on for this takeoff. Maybe set a higher altitude over here, 35,000 feet. Got another 35 minutes to go for this flight. And the heading should be less than that. It should be similar to our runway heading. It's runway 16. So I'm gonna use a heading of 153. I have to roll this down, all the way down. use maybe the Lnav. You only need to activate this to have the Lnav on, and we have a ready flight plan over here, so we can use the L navigation. We can arm also in the vertical navigation, but I'm gonna leave this like that for this flight. So here we have the Lszh heading over here, 153. So we're ready for takeoff right now. So I'm only having to move the thrust levers. I'm gonna be showing you maybe a better view of this circle while in takeoff. So here we have it. I'm gonna move the thrust levers all the way up to the takeoff go around position and disconnect the parking brake. Maybe decrease the range over here so you can see better what we have. 100 knots. (150), 160, we can take off. We passed B1 and B rotate. Retract the landing gear. Trim down a little bit the aircraft. And we can start turning to the left. Our airspeed is quite good right now. You can see our runway heading here. We're turning around from that. The horizontal situation indicator and primary flight display, the navigation display. Our altitude is 4,800 feet right now. It's keep increasing with 5,000 feet per minute. So I'm gonna decrease the rate of climb a little bit. Trim down the aircraft to hold the airspeed a little bit higher. You can see the airspeed over here, 160, 1, 2, 3, 4, 5 knots. (184 knots). Just keep increasing. 190. We also need our altitude over here, 7,200 feet, and a rate of glide 3,000 feet per minute. And here we turn into the flight path. The first waypoint, the second waypoint, the third waypoint, and back into the airport. And we have 20 minutes to go for this flight, for this video. So I'm gonna make it as fast as possible. You can see the night view here of the aircraft and the dome. So you can see how I'm turning the aircraft using the control wheel. Also trying to pitch up a little bit or down when I need it. You can see the Boeing 767. It's a very nice aircraft. I like flying it. You can see some view of the Switzerland here. This is Rick, and maybe a little bit to Germany. Over here we're going to be overflying it. And you can also see the star sign above us. So we have another 37, yeah, another 18 minutes to go. So I'm gonna retract the flaps to increase the airspeed a little bit. So I'm gonna have to use this knob. You can use Mach 0.8 for this flight. So you're gonna see the airspeed increasing rapidly over here. We have 488, 90 knots. Ground speed, I believe 500. Oh no, this is the Mach speed, 0.5, and this is knots. It's 250 knots. You can see 258. And you can see the pointer here is increasing. And here is the maximum speed. For this altitude, it's a little bit lower than our maximum airspeed, which I said this tab over here using the autopilot airspeed. You can use the speed and the level hold here. Yeah, you can see displayed over here altitude, hold, and nav. The primary flight display I was telling you of the horizontal situation indicator. You can see our waypoints over here and our flight plan. We keep climbing. We are at 20,000 feet, 20,200, 2,000 feet per minute. If I decrease my rate of climb, the airspeed is going to increase quite rapidly. You can see the autopilot section here. The autopilot disengage and the autopilot engage button. If I press this, it engages the autopilot. We have the command on here, which turns the aircraft a little bit. Now is in the autopilot command. It manages the heading over here. Speed altitude command, you can see it displayed here. Our airspeed is 0.615 knots. No, 0.635 Mach 309 knots is increasing quite rapidly. So you can see the maximum airspeed right now. The marking is approaching our flight airspeed. So maybe I'm gonna use yeah. We have to fly using the autopilot, so I'm gonna use the vertical speed mode, 2,400 feet per minute. It's approaching our waypoint, the autopilot, and now it's turning the aircraft. So I'm gonna disconnect the autopilot here. You can see the warning, and fly a little bit manually. We have another 14 minutes to go, 4 minutes to go for this flight, so we have max 0.7. I'm gonna climb a little bit faster to the maximum altitude. I'm gonna show you some of the waypoints. So we have 14 minutes to go. So here we have the chemtrails that I was telling you. Been created over here, and we are approaching our maximum altitude. So we're gonna start turning back into the airport while trying to keep climbing a little bit. We have 3 minutes to go, so we have to be very fast. You can see still the warning here that I disconnect the autopilot. You see the chemtrails here from the Boeing 767 as it keeps gliding and turning. I'm gonna come here and start descending now, because we are already in the turn back into the airport. I'm gonna use a direct 2. The final fix. So I'm gonna decrease the airspeed. While keep turning to the airport. So I'm gonna keep descending down to the airport. We have to decrease the altitude a little bit. It's gonna take some time. So decrease the airspeed a little bit more. Safer marking. Here. we're very close into the airport, so we're gonna be level off a little bit. And have another maybe 5 and 3, 8 minutes to go for this flight. Use manual thrust for this flight. We're very close to the final fix and the approach over here, as you can see. We have 6 minutes to go, so we need to be a little bit fast. We are also in a good altitude, set for landing. Here we have the runways over here, blinking. We have 6 minutes to go, so I'm gonna try to come as close as I can, make a nice approach. Try to come a little bit closer to the runway. Yeah. Here we are, runway 1416. So we have the river over here, as you can see. So we are in a good position to land, actually. I'm gonna do most of this manually. I'm only gonna use the localizer here, the LNAV maybe, and the lock mode, which is gonna turn out the LS on. So I'm gonna use maybe the speed brakes and the landing gear to slow down the aircraft for landing. We pass through the river and we have the runway inside, and we have another 4 minutes to go, so maybe use some flaps. You can see the landing gear. Here we have the runway. We have 3 minutes to go, and we are in a very nice position. Use a little bit more flaps. Maybe use flaps 30, I believe. You can see how nicely aligned we are. Here is the ILS localizer in the primary flight display. Here we have it, we are aligned with the runway. Here and here in the navigation display, our airspeed is correct, so I'll make a few small adjustments for the landing. We have 2 more minutes to go, so we have to be a little bit more fast. We have 1 more minute to go. We're just barely gonna touch down the runway. Before the record time is going to end. So I'm gonna bring this a little bit lower. And here we are. We just touched down and landed. We can go around also if we want.